Welcome to a new test and teardown video. This time it's a Hewlett Packard spectrum analyzer. Yeah, the real old fancy type with plug-in modules. So this model I got consists of a 8553B spectrum analyzer RF section here, and this is the one with two ranges, 0 to 11 and 0 to 110 megahertz. The first thing I really want to show is something I really like about this unit here. And this tiny little detail here, this is where you switch between the ranges. Just check this out. Isn't that just cute? You can barely see. Look at that. Here you go. Isn't that just really nice? So they just, have a sense of details, make it look real sexy. And of course there's this little tuning here, and this is the sensor frequency you set up and all that. So, and then you have the IF section. So this is a radio receiver that mixes down to IF, and in RF you set up the scan and all sorts of levels, blah 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 blah, all this. And then there is a display readout section. It's called 141T display section with storage. It is analog storage for the CRT. It is built into the CRT and the Phosphor and the extra holding beams and all those. So this is a really special CRT, and it's of course done with this store and fast and standard erase and all that kind of stuff. So in non-storage it's removing the high voltage for the storage beams that adds energy to already written phosphor particles, and then they light up and then energize and they kind of suck in extra electrons, and then you add these. It's just fascinating the way that they are working those storage CRTs. So the thing is, this unit is not working. I was told loud and clear it is not working. And I think I remember it was something with the power supply. It's blowing up fuses, it's exploding and whatever it is. So I don't know what we can do about it. I can probably take out the plugins and just remove as much as possible and just try and see if I can get at least a little beam on the CRT. It's a little bit sad because I got other plug-in modules, I got other spectrum analyzer plugins, I even got the tracking generator, yes, the one with nixie tubes and all that, can do counting and all that. Maybe I will put this in a separate video, or if I'm real fast getting this one up and running, maybe I will play with the rest of the optional extras I got for this one. So thanks a lot again for all the fantastic donations to my channel. I love it. Keep them coming, and I will be able to create much more cool content. I will of course not power it up before we open and have a deep inspection. So let's try and play around with this unit. I just took the top cover off first, and maybe I want to show how to pull the plug-in modules, because there is a way you pull this to the left, and there you have it. Now it unlocks, and the way that this actually works is much easier to show right here, because if you see on this side there's this little pin, and now I close it and then click, and then it goes out and lock in behind this little locking thingy here. So that is how it works. So now you pull out both of the modules at the same time, by the way, and then they are locked together by something else. But anyway, so here they are connected by both DC low frequency, medium frequency here, and high frequency signals as well. And the reason why I really want to get this unit up and running, that is because it's quite easy to get all sorts of plug-in modules all the way to as many gigahertz as you want. So it could be really cool to have this spectrum analyzer up and running, so I can go and get these modules, because they are available on all the different ham radio flea markets and all that for nothing, because they don't have the other things, and then sometimes these pops up. So that is why, and there are tons of these available. So yeah, let's just see what happens. But so far we can enjoy this super cool CRT with the deflection. Here we go with the deflection like that. And of course there's a little switch down here. Ooh, this you can't move at all. And this is the little fan unit. It's a little bit funny with the power supply transistors, and they're mounted directly on the fan unit like that. And this is of course a little bit dirty. And look at the size of this transformer. It's just all the way around here, really big and hefty. And it is of course far away from the CRT, with a lot of different metal parts in the way, and that is definitely a good idea to get a nice stable picture. And we also got all the capacitors and good stuff out here, so I better go and monitor all that. How's this looking? Take away the side. I can see we got some screws missing on the side panel, so definitely somebody was in here poking around. And yeah, I know we got some funny things going on here. Also a little bit of corrosion or whatever that is. Not good. So to get the two plug-in modules apart is actually easier if you flip them upside down like I did here. And then there are two things to note. There's just a push in here with your fingers, see, and this releases this one. And at the same time you lift it up only here at the front, not on the back, because here on the back it is locked here, see. So this one goes in there first, and then it flips down and then clicks, locks. And here's the interconnect from the RF to the IF section. That is like that. And here's a little bit of a special Canon connector with, it looks like the 50-pin connector, but we also got two little high frequency coax connectors there as well. So I flipped it upside down, and let's have a little look at what is going on inside this fantastic thing. We got some more of those power supply transistors. We got also the other ones I mentioned earlier. They are down there, and yep, here we go. So we've got 4 of these fan cooled transistors, and that will be the transformer. But look at this, I think this is important to mention. Here is a little mains entry filter, and this one is classic for shorting and causing all sorts of problems in here. So this is also something I want to check out. And we got some more high voltage capacitors. There's probably just filtering mains entry. And then I bet here we got all the CRT relevant stuff, because see, without any plug-in modules I should still be able to at least get a dot or anything on the screen. Then that is my idea. So hopefully here we'll have the deflection stuff and some high voltage. Let's try and look beneath the cover. So that is just the storage control PCB. And look at those potentiometers. It's because they are at a very high voltage potential, and that is why they suck all this dust and nasty funkers. Maybe it's the dust that creates this. And I thought this would be the deflection amplifiers, but I don't really see any deflection amplifying transistors of any sort, really. I would expect them to be in a little pair, a little balanced pair, or some with a little heat sink or something like that. But is it really sweeping the screen this slow so you can use those tiny little transistors as we see here? I don't think so. I don't really. Yeah, well, anyway, this is the high voltage supply. There's a little flyback converter going on here. There's a little transistor for that probably here. And of course, this is at a few kilovolts potential, so everything here sucks up a lot of dust. So I definitely want to go and give this a lot of compressed air. But look at that little sexy serial label soldered into place. Isn't that just wonderful? I love it so much. We got some high voltage feedback resistors. Definitely some high quality stuff there. And look at the aluminium part here. How dirty that is. Yeah. Time for a little bit of cleanup. And this part here at the very back, I believe that is the tripler. So you get AC signals into it, and we got diodes and capacitors in one big sickety-sackety up and down, and then you have the red wire here. This goes to the top of the CRT. That will be the high voltage positive anode supply. So after a lot of cleaning, everything looks nice and shiny again. And I actually think that I found the missing deflection amplifier. See, here we got some deflection signals, and they go, here we go with the little deflection amplifier. And the inputs there goes, of course, to the plug-in module. So at least I figured that out. I think I want to try and power the tube without anything at all. I hope the center voltages will be more or less in the middle. Without biasing the deflection amps correctly, you could get a beam that is quite a lot out of focus. So that in mind, we will see if there is any beam or if anything explodes. We of course got all the rectifiers and the power supply parts down there. And yeah, hopefully that is okay. Here at the side of the beam, we got a few extra signals because this is a very special CRT. And look at that. Here we got some flat cable, high voltage flat cable going through this hole. And we also got some other wires for that. And that is, of course, one of the high voltage point. And up here, it's delivering voltages to a few of the special storage plates all the way up in the front of the CRT. So let's have one more little picture from the power supply, the high voltage power supply, when it is now nice and clean, and we can see what is going on. And here we go with the high voltage rectifiers for the cathode system, of course, and this is of course the anode system. So here's my first power up. Line is on. This is on, and then we just slowly crank up. And so what have we got? Let's put everything in non-storage. Everything is in the middle. Maybe intensity. Lamp is on, so this is good. The fan is going. Don't be scared about that. So here is 220 volts. It's using 48 watts. And we don't see any. Here we go. Look at that. Okay. So this is the erase beam. And this is the non-storage. Well, look at that. Here we got the storage up and running fast, and then okay, I'm actually quite happy about this. The funny thing is it's looking like this is the erase beam, and then we go back to storage, non-storage. Okay, well, let's try and plug in some of the other modules. There's probably a reason for the beam not to be on the screen or anything like that. It could be just way out due to deflection. So there's probably something with that. So let's try and see what happens. Like that. So let's just power it up. Are you guys ready? It is of course using a lot more power. We've got a few lamps up and running. Oh, look at that. We even got a sweep. And we got a little blink blink. So that is the marker. Focus is good. Intensity is probably way too... Okay, so scan. Scan time. Oh, look at that. Is of course the 0-Hertz. It is not blinking or anything here in reality. So let's try and change the shutter time here. So that is a little bit better, isn't it? Okay, what else can we do? Bandwidth? Yes, yes, yes. And there you have it. Frequency is there. Scan. I mean, this one I cannot move, so there's a mechanical problem. Let's see the yeah. Okay. Haha, even that. Oh, look at. I mean, manual scan. So it's using 130 watts at the moment. That fan I need to fix. So here's intensity, here is focus. Okay, so while we have a beam before it blows up or anything, let's see if we can get this storage thing to work. So here, yeah. So it should store, and then you should change. So how is this persistence? Fast? Nah. So intensity is all gone. And then you erase. Okay, here you go. And so there's something that is not working. It seems to be. See, this is this. I don't have a lot to say about that, but it's really, really bright. But not. See, the idea is probably there's only one little sweep going on, and then it will actually peak store this one. And if I move, see, then you see the old and the new. It's just too bad it's really, really bright. So the camera here is not picking it up real good. Let's try and see if I, yes, like that. See, erase, and let's see. Yeah, here we go. Yeah, this is. So this is the storage, this is persistence. I need to learn how to use this because it is not working really good. Here you go, actually. I think we have any. Oh yeah, here we go. Haha, of course it can do that. Look at that. Here it is a stored picture. Erase, and then store the picture. And the idea is you can crank down. I had it up and running before, much better. Well, it is one funny analog storage of that. The bandwidth of the IF is just really weird, and of course this is the 0-Hertz beat we see because there is no input in case this thing actually works. So I will get a signal generator and play a little bit with this. So now I am in the 0 to 110 megahertz range. I set this up for a bandwidth of 100 kilohertz, and scan width per division is 10 megahertz. All right. So with a center of 50 megahertz, as you see here. So if this is 50, then the idea is you move this tuning. Look at this, the 0 beat. So if I have this at exactly here, right, then it is 10, 20 megahertz per division. I should of course be able to move this picture a little bit to the left, so this dot here should be exactly at the 0 line. So what you see here is my signal generator, 20 megahertz input. If I remove the input, you see here, so just a very, very weak input. And then you can of course play with the log level and see how sensitive it can be. And you can also just give it some more input level from my generator. I put in an extra attenuator here because I cannot move this attenuator dial here, so this is probably the problem, but I expected it to be blown up and everything like that because I heard that it was completely defect, but it seems not to be the case. Let's try and focus on the screen instead. And then what else can we play with? This is manual scan. No, we're not doing that. Oh, that is some funny thing. So you can remove the noise. That is weird. Why would you baseline clip? What is the idea with that? And then you have the... Okay, so this is scan time per division, how fast it is scanning. So of course, if it's scanning real slow, you get a much better filter bandwidth, and then you can add some more filter like that, or no filter at all, and then change the speed and the filter to get the curve you want. So let's try and zoom in on those, the 20 megahertz. So if I move to a 5 megahertz, 2 megahertz per division, and then I dial my frequency down to 20 megahertz for the center frequency. Here we go. So now I have 20 megahertz in the center, and the dial here is also 20. So how about that? And we can of course change the bandwidth here, and get a much better bandwidth like that. And we can even zoom in 1 megahertz, 0.5. Ooh, now it gets much more aggressive. But here is my input, and it's funny thing, it's not symmetric, but this is just how this IF is. It's probably not that well aligned and everything like that, and but it's not looking that bad, is it? I'm actually really happy about the way this works. So now I can of course go and clean this up and try and see if I can figure out what is the problem with this input attenuator. I mean, how hot? Oh, look at that. And it's probably completely broken inside or something like that. Yeah, let's go and open this unit and see what we can do about that. So before I go and play with the RF section, I think it is of course also a little bit of fun just to have a very, very quick run through the IF. So this is the IF. Let's look one more time here at the front. This is the 8552B, and this one works as far as I can see. We got some different features with log or linear, and it's quite sexy with the bulbs up here. And let's show that. And it is done like that. How about that solution with all the little bulbs and things? And of course we got some plug-in modules. Maybe Yeah, I will try and open it a little bit more. There's a nice warning here about voltages 250 and minus 100, and this is of course due to deflection. So here it's driving deflection amplifiers, and we got some fuses and some power supplies stuff. Yeah, 100 here and all that. And of course there's a little power resistor. That is a little bit weird. It is probably the most compact you will see in a long time. I mean, look at the little extra shields in here, and so everything is completely isolated in tiny little rooms. And then there's a little top shield here I just removed, and then there's of course this top again, and then there's this one was placed over here. We got a few things I want to show inside this module. So up here we got some mixers. You can see the diodes there at the top, and you can see the little transformer down under the diodes. It is that compact they tried to make it. And we got of course some IF filters here. That will be low frequency IF or video bandwidth filters. We got some oscillator modules, so some more oscillators and mixers and all that. And that will be crystal filters for the higher frequency. Look how nice all that looks with the transparent glass. I kind of like that a lot. That is really cute. And the rest is just, yeah, tons of transistors and all that. We got some power transistors in here. I really don't want to take up everything here because it is insanely fragile, all this kind of stuff here. And since this thing is working so good, I think we just want to keep it like that. I think the holes here, the idea is you probably just stick in a screwdriver and then carefully twist, and this way you can take up some of the different modules. So that will be it. I think they are all down in there exactly where they are supposed to be. So here's the power supply. Got a little bit of adjustments here for the different power supplies, and they even got some test points neatly located so you can access them, but you somehow need a riser card or something so you can access everything here while it is still in there, and you have the other module and all that. It's probably not the easiest way to service things. Isn't this just beautiful? All the crystal filters. And it says 73 on the crystals. Is it really that old, this unit? You better believe it. They were really, really ahead of their time. I am really, really impressed if this is the case. So here is the RF section again. I took away the two outer shields so we can see what is going on in here. And this one is just beautiful. And of course, everything is mounted inside one big, hefty, casted aluminium chassis. And then you have the different plug-in modules, oscillators and mixers and everything like that. And this is truly a very interesting sweeper, so to speak. So the way that this works is it's an analog sweeping system where the oscillators just freely swinging and controlled by analog voltages and then mixed together, and then they generate the IF output that goes to the other module. But look how nice this is. And here's the frequency setting gearbox. Look at that. And it's all controlled by analog voltages and potentiometers. Isn't that just fantastic? Here's another one that is directly connected to the fine and the settings here, and I'm a little bit impressed how this analog can be so precise in doing all this. Here we got the different settings, switches and all that. But let's see the other side. It's quite heavy, as you can imagine. I don't know how we can video this. It's a little bit difficult, but I think you get the point. Again, I really don't want to open here and get into all these modules, because here it's a lot more hefty RF, well, hefty and hefty. This one is only capable of 110 megahertz, so this is really the slow-mo one of them. The next one is a 1.2 gigahertz, and then there's also a 40 gigahertz, and there's probably a lot more plug-in modules for this type of plug-in capable spectrum analyzer. And look at the feed through capacitors, DC filters, and low frequency stuff like that. And remember, I was complaining about the attenuator not being able to be dialed, and look what happened. Ta-da-da! Now you can move this nice and fine, and it looks like there is actually two things going on here. There's, of course, this RF attenuator, but at front here, it's impossible to see. Yeah, maybe I can show this. Yeah, maybe you can see. There's actually a normal switch, but a lot smaller than these, but still this sort of open switch. And then there is a mechanism with a little bearing and springs and all that. And this thing up there was just completely, the lubrication up there just turned itself into chewing gum or something like that. So I gave it all a lot of contact 61 in all sorts of directions here, so that it could go all the way in. And look, it's just moving really, really nice and fine. So I'm super happy about this. So now I can put it back together and put on my top and bottom covers. And there you have it for the RF section. Beautiful module. Let's show my little extra plug-in module. So this one is the low frequency spectrum analyzer for audio range and all that kind of stuff. So look at this. It is called 8556A. So it's the first version of this one. And we've got two ranges, 0 to 300 kilohertz and 0 to 30 kilohertz for audio range, and that is so nice. We got an input, of course, high impedance input for audio experiments, and there's also a tracking generator output. That is also very, very neat. And of course the input level. Scan with exactly like the other one. Of course, now everything here is much lower values. Look at the hertz here, 20 hertz. Bandwidth also in hertz and in kilohertz, of course. So you can sweep maximum 10 kilohertz at a time, and then you move, of course, your center frequency, for example 10 kilohertz and a bandwidth of 10 kilohertz. I really like this module. There's just one tiny little problem. This one is not compatible with my with my IF section. I will show you this in a second. Here on top it says it is important, operated with a modified. I do not have a modified, so you either this one or that one. This is the B version I got of my IF section, but it's not modified. So I need to go and consult the operating manual for the details. And I really don't want to modify my IF that is already working to get the low frequency section up and running. But we could, of course, open this one and have a look. And I believe this one is doing exactly the opposite. It's, of course, mixing up to the IF instead of mixing down like the higher frequency spectrum analyzers they're doing. But anyway, let's try and open it and have a look. And of course, we got a little warning here about high voltage. And that is, of course, for the deflection system. That's also on this board. Beautiful gold plated tracks. And we've got some really funny things about the split ground plane and all the signals that's actually crossing a split ground plane. But we got some capacitors, I don't know if we can see this, right here and up here, that will make it so that high frequency signals can actually cross a broken ground plane, but then they can be at a different DC potential. So that is a little bit special. Normally you're not allowed to cross a ground plane with signals like this. So I really don't recommend this type of design style. And that is, of course, the interconnect. From the bottom here, it looks a little bit like the other one, but also, of course, much lower frequency ranges and all that. So let's have a little look from this side here. We got the different modules in a classic Hewlett Packard build module. These modules, they are definitely reusing in all sorts of their different units. I've seen these, I don't know how many times in all sorts of Hewlett Packard units with different lids and different functions, of course, but this outer casing here is exactly the same. In this one, there's of course a down converter, up converter instead of a down converter, because that is how it works. So here's the tracking generator output, input from this one. We've got some megahertz. How many? 47 megahertz local oscillator. And then there is a test point of 400 kilohertz and the power supply as well. We got some pre-amplifier stuff going on here. And so, of course, some mixers. Ooh, this one looks like it is a little bit broken. Not so much. But again, it's more or less the same kind of basic features, just like the much higher frequency unit. Again, we got some potentiometers and a gearbox and a little readout system, and again this little range switch. It looks like it's not the best when it comes to isolation distance to mechanics, but again it is really a compact build, and that is just how it is. Oh, those connectors are really nasty and needs to be cleaned. Yeah, of course I did clean all the other connectors in my mainframe and also in my other plugins, so I hope it will be nice and good. So I think that is more or less all I wanted to show about this fantastic plugin module spectrum analyzer. Now I'll go and clean everything again and assemble everything. I also know I got the mechanics, by the way, so I can plug in the nice plastic mechanic here, so it's going to look real nice and shiny. There was just one tiny little thing I really needed to add as well, and that is this CRT. So the text here, oh damn, so the text here is inside the glass, and we got some more text written there and over here, and I think it is like that. See, I think that is quite sexy with the grids and everything written inside that CRT. I'm really happy that it actually turned out to be working. So thank you very much for watching. See you around. Bye bye.